Along the edges of America's largest ports, there are channels so wide and deep that they appear natural. Cargo ships pass through them without slowing. Container vessels, carrying thousands of steel boxes, glide across water that seems as though it has always been there. But much of that water was never supposed to exist. Entire harbors were carved into existence by machines that consumed mud, sand, clay, rock, and sometimes the men working beside them. The modern ports of America, places that move billions of dollars in goods every year, owe their existence to giant dredgers, floating industrial monsters. Some were longer than warships. Some operated day and night for years. Some could move tens of thousands of tons of material in a single day. Their purpose seemed simple: dig deeper, dig wider, make room for larger ships. But beneath that simple mission was a problem that industrial America could not ignore. The nation was growing. Factories demanded raw materials. Cities demanded fuel. Railroads demanded connections to global trade. Ships were becoming larger with every passing decade. Yet nature refused to cooperate. Rivers silted up. Harbors filled with sediment. Channels disappeared beneath layers of mud. Ports that had once been prosperous faced a slow economic death. Something had to keep the waterways open. Something had to reshape coastlines themselves. The answer arrived in the form of giant dredging systems, machines designed to wage war against geography. They dug channels where none existed. They deepened rivers. They created artificial harbors. They transformed isolated coastal settlements into gateways of global commerce. But progress came with a cost rarely remembered today. Workers labored beside machinery powerful enough to swallow locomotives. Men disappeared beneath collapsing spoil banks. Others were crushed by cables, struck by machinery, or lost during storms while operating floating industrial platforms far from shore. The ports survived. The ships grew larger. Trade flourished, and the names of the workers slowly vanished from memory. Today, the channels remain. The harbors remain. The industrial empire they helped build remains. But a question still lingers beneath the water. How did a fleet of floating machines reshape America's coastline? And why did so many people have to risk everything to make it happen? Welcome to History Forged. This channel explores the rise of industry, the evolution of engineering, and the people who worked inside the world's most powerful machines. If that sounds interesting, subscribe and join us for more industrial history and engineering documentaries. Long before giant dredgers appeared on America's rivers and coastlines, the nation faced a problem that was both simple and relentless. Waterways refused to stay where people wanted them. A river is not a fixed object. A harbor is not permanent. A channel is not guaranteed to remain open. Nature is constantly moving sediment. Sand drifts with tides. Mud settles in quiet water. Storms rearrange coastlines. Floods transport enormous quantities of material downstream. Every year, rivers and harbors slowly reshape themselves. For centuries, this process limited trade. A settlement might possess an excellent harbor one decade, and a dangerous, shallow approach the next. A river capable of carrying large vessels could gradually become difficult to navigate. Entire ports could decline, because water that once supported commerce became too shallow for ships. This challenge became increasingly severe as America expanded. During the 18th and 19th centuries, the young nation depended heavily upon maritime transportation. Roads were often poor. Railways did not yet dominate long-distance freight movement. Water was the fastest and cheapest way to transport large quantities of goods. Farmers relied on rivers to move crops. Merchants relied on ports to receive imports. Manufacturers relied on shipping networks to connect markets. The economy depended on water, yet the waterways themselves were unreliable. One of the greatest obstacles was sedimentation. Every river carries material: tiny particles of clay, silt, Sand, organic debris. When water slows, much of that material settles. Over time, deposits accumulate. Channels become shallower. Navigation becomes more difficult. The process is gradual enough to seem harmless at first. Then, one day, a vessel runs aground. A shipping company changes routes. Trade begins moving elsewhere. The economic consequences can be devastating. Port cities understood this threat better than anyone. Their prosperity depended on maintaining access to deep water. A harbor might possess excellent warehouses, skilled labor, rail connections, and favorable geography. None of that mattered if ships could not reach the docks. Depth became destiny. The problem intensified during the 19th century because ships were changing. Early sailing vessels were relatively modest compared with what would come later. As trade expanded, shipbuilders constructed larger vessels capable of carrying greater cargo volumes. These ships required deeper channels. A harbor that comfortably accommodated vessels one generation might become inadequate for the next. Growth created its own crisis. Success demanded larger ships. Larger ships demanded deeper water. Deeper water often did not exist naturally. Many of America's future industrial centers faced exactly this challenge. Natural conditions were often imperfect. Some harbors were too shallow. Some river mouths accumulated sediment rapidly. Others suffered from shifting sandbars that created hazards for navigation. Communities recognized the opportunity represented by maritime trade. But opportunity alone could not overcome geography. Nature imposed limits. Those limits threatened economic development. Before mechanized dredging, solutions were labor-intensive and often ineffective. Workers used hand tools. Small crews attempted to remove sediment manually. Simple drag devices were pulled through channels. Limited excavation projects removed material from critical areas. These methods sometimes provided temporary relief. They rarely solved the underlying problem. The scale was simply too large. A river might deposit millions of tons of sediment over time. Removing that material by hand was an endless struggle. Every effort seemed temporary. Every victory seemed fragile. The water always returned carrying more material. This created a cycle of frustration. Communities invested resources into maintaining navigation. Nature steadily erased those efforts. The challenge was not defeating a single obstacle. The challenge was fighting a continuous process. Industrialization made the stakes even higher. By the late 19th century, America was transforming into an industrial giant. Factories demanded raw materials in unprecedented quantities. Coal moved through ports. Iron ore moved through ports. Timber moved through ports. Manufactured goods moved through ports. The volume of trade increased dramatically. Waterways that had once supported regional commerce now carried national importance. A blocked channel no longer affected only local merchants. It could affect entire industries. It could influence employment. It could shape the economic future of cities. Ports began competing aggressively for shipping traffic. A deeper harbor attracted larger vessels. Larger vessels brought more cargo. More cargo generated more wealth. Infrastructure investment became a survival strategy. Communities understood that maintaining access to deep water was no longer optional. It was essential. The challenge extended beyond existing ports. America was expanding geographically. New regions sought connections to national and international markets. Developers envisioned entirely new harbors. Engineers imagined channels cut through difficult terrain. Industrial planners looked at coastlines and rivers, not as fixed natural features, but as systems that could be modified. Yet these ambitions collided with a stubborn reality. Moving Earth underwater is extraordinarily difficult. Unlike construction on land, underwater excavation limits visibility. Currents interfere with operations. Material behaves differently. Weather introduces additional risks. The work is slow, complex, expensive. Before powerful machinery emerged, many projects remained impractical. The technology simply did not exist to reshape waterways on the scale industry demanded. That gap between ambition and capability became increasingly important. The nation needed deeper channels, larger ports, more reliable navigation routes. But traditional methods could not deliver them. Economic growth depended upon solving a problem that nature recreated every day. The old system was failing. Manual labor could not keep pace with industrial demand. Harbors continued filling. Channels continued shifting. Trade continued expanding. Pressure mounted from every direction. Merchants wanted access. Industries wanted capacity. Cities wanted growth. The country wanted connection. What America required was not merely a better tool. It required an entirely new industrial system. A system capable of moving unimaginable quantities of earth and sediment. A system powerful enough to reshape rivers, coastlines, and harbors themselves. And somewhere between the demands of commerce and the resistance of nature, engineers began developing machines that would transform the nation's waterways forever. Machines so large and powerful that they would eventually create some of America's biggest ports. But before those machines could reshape the coastline, someone first had to imagine how a floating machine could wage war against an entire landscape. The first attempts to solve America's dredging problem were modest. Engineers did not begin with floating industrial giants capable of moving entire sections of coastline. They began with a simple question: how do you remove material from underwater when workers cannot easily reach it? For centuries, the answer involved variations of the same approach. Buckets, scoops, drag systems, labor-intensive methods that removed small quantities of sediment at a time. These techniques could help maintain a local harbor or clear a limited obstruction. They could not support an industrial nation. By the middle of the 19th century, the scale of the challenge had changed dramatically. Steam power was transforming transportation. Railroads were expanding across the continent. Factories demanded reliable supply chains. International trade was accelerating. American ports faced increasing pressure to accommodate larger vessels carrying greater cargo volumes. The old methods no longer matched the new reality. The problem was no longer local. It was national. This was the environment that gave rise to mechanized dredging. Steam engines offered something previous generations lacked: continuous power. A machine could operate for hours, sometimes days, performing work that would have exhausted hundreds of laborers. Engineers quickly recognized the potential. If steam could move locomotives and power factories, it could also remove sediment from rivers and harbors. Early steam dredgers appeared as practical experiments. Mounted on barges or floating platforms, they used bucket systems to excavate underwater material. Chains of steel buckets rotated continuously, scooping sediment from the bottom and lifting it toward the surface. Compared with manual labor, the increase in productivity was astonishing. For the first time, waterways could be maintained on a scale that matched industrial growth. Government agencies took notice. Private businesses took notice. Port authorities took notice. Among the most important supporters was the federal government itself. America's expanding economy depended heavily on navigable waterways. Maintaining those waterways became a matter of national interest. The organization that would eventually play a central role in this effort was the United States Army Corps of Engineers. The Corps increasingly became responsible for improving rivers, maintaining navigation channels, and supporting large-scale dredging projects throughout the country. Their influence would shape American waterways for generations. The partnership between government investment and industrial technology accelerated development. Dredgers grew larger. Their machinery became more sophisticated. Their capabilities expanded. Engineers experimented with new designs. Bucket dredgers remained important, but additional systems emerged. Cutter suction dredgers used rotating cutting heads to loosen material before powerful pumps transported sediment through pipelines. Hopper dredgers collected excavated material within large onboard compartments before transporting it elsewhere. Each innovation addressed a specific problem. Hard soils required different solutions than soft sediment. Confined waterways demanded different approaches than open harbors. The machines evolved because the challenges evolved. Expansion followed naturally. Ports that had once accepted limitations began imagining possibilities. A shallow harbor was no longer necessarily a permanent condition. A difficult river mouth could potentially be modified. An obstructed channel could potentially be deepened. The geography itself became negotiable. Few developments illustrate industrial ambition more clearly. For most of human history, communities adapted themselves to waterways. Now waterways were increasingly being adapted to communities. The relationship had reversed. Throughout the late 19th and early 20th centuries, dredging projects multiplied across the United States. Major ports along the Atlantic coast expanded. Channels serving Gulf Coast shipping routes deepened. River systems supporting inland commerce underwent extensive modification. Industrial centers competed aggressively to attract maritime traffic. Depth became a strategic asset. The deeper the harbor, the larger the ships. The larger the ships, the greater the economic opportunity. This competition encouraged ever larger projects. Each successful dredging operation created pressure for another. A neighboring port might deepen its channel. Competitors would respond. Shipping companies upgraded fleets. Ports upgraded infrastructure. The cycle repeated. Growth generated demand for more growth. The machines responded by becoming larger and more powerful. By the early 20th century, some dredgers resembled floating factories, more than traditional construction equipment. Their crews lived and worked aboard them. Their machinery operated continuously. Their output reached levels unimaginable to earlier generations. These were no longer simple maintenance tools. They had become industrial systems. Entire landscapes could be altered through their operation. Rivers were widened, channels extended, harbors transformed. Artificial waterways emerged where none had existed before. The economic consequences were enormous. Cities that secured deep water access often experienced dramatic growth. Manufacturing expanded. Employment increased. Investment followed. The dredger became an invisible partner in industrial development. Most people never saw the machine responsible. They saw only the results: a larger harbor, a busier port, more ships arriving, more goods moving, more wealth circulating through the local economy. The machine remained in the background, while its effects reshaped entire regions. Yet expansion carried risks. As projects grew larger, operations became more complex. The machinery increased in size. The crews increased in size. The stakes increased in size. A dredger working in a small harbor represented one thing: a massive industrial dredger, operating continuously in difficult conditions, represented something entirely different. The machines now occupied environments shaped by weather, water, heavy equipment, and constant motion. They worked around tides, storms, currents, mechanical failures. Every new level of capability introduced new forms of danger. The industrial system was becoming more powerful. It was also becoming more unforgiving. The giant dredgers that would eventually create America's biggest ports were no longer experimental curiosities. They had become essential infrastructure. Entire cities depended on them. Entire industries depended on them. Entire trade networks depended on them. But understanding their true impact requires looking beyond economics and expansion. To understand why these machines became both celebrated and feared, it is necessary to step aboard one of them, to hear its machinery, to feel its vibration, to watch thousands of tons of earth rise from the bottom of a harbor, and to understand how a floating machine could possess enough power to reshape geography itself. Seen from a distance, a giant dredger can appear strangely calm. It floats on the surface. Its hull rises and falls with the water. Smoke drifts from exhaust stacks. Lights glow across the deck. Nothing about the scene immediately suggests violence, but beneath the waterline, the machine is engaged in a constant act of destruction. Its purpose is to tear apart the bottom of a river, harbor, or channel and move the earth somewhere else. The calm surface hides an industrial process powerful enough to reshape geography. The largest dredgers of the industrial era were not simply boats with digging equipment attached. They were floating excavation systems, entire factories dedicated to moving sediment. Every component existed for a single purpose: remove material, move it, repeat, hour after hour, day after day, sometimes for years. One of the most influential designs was the cutter suction dredger. At the front of the machine sat a rotating cutter head. The device resembled a massive steel wheel covered in teeth. Depending on the project, it could be several meters across and weigh many tons. When lowered to the bottom, the cutter rotated continuously. Its teeth attacked clay, compacted sediment, gravel, and other materials that ordinary suction systems could not easily remove. The sound was rarely heard above water, but workers nearby described the vibration traveling through the hull, a constant mechanical growl, a reminder that the machine was chewing its way through the landscape below. Behind the cutter operated the true heart of the system: powerful pumps. These pumps generated immense suction. As the cutter loosened material, water and sediment were drawn into large pipes. The resulting slurry traveled through steel pipelines that stretched across the project site. Some pipelines extended for miles. The machine was not merely digging, it was transporting entire sections of the earth from one location to another. The volumes involved were staggering. Thousands of cubic yards could be moved in a single day, millions over the life of a project. Material removed from a harbor might be deposited elsewhere to create new land. Marshes could be reshaped. Artificial islands could emerge. Coastlines could change. The machine was simultaneously an excavator and a landscape creator. Bucket dredgers operated differently, but achieved similar results. A continuous chain of steel buckets rotated around a large framework. Each bucket descended into the water, scooped material, and carried it upward. At the top of the cycle, the bucket emptied its contents into conveyors or barges. Then it returned to repeat the process, again, and again, and again. The rhythm was hypnotic. Chains rattled, metal struck metal, steam hissed from machinery. The machine consumed the riverbed one bucket at a time. The scale of these systems often surprised observers. Some industrial dredgers were longer than city blocks. Their machinery weighed thousands of tons. Massive winches controlled positioning. Heavy cables stretched across the water. Anchors held the vessel in place while excavation proceeded. Everything was oversized because the task itself was oversized. Nature deposits sediment continuously. To overcome that process, the machine needed overwhelming force. Power came first from steam and later from diesel engines. The steam era created a particularly dramatic environment. Boilers consumed enormous quantities of fuel. Engine rooms radiated heat. Pipes carried high-pressure steam throughout the vessel. The machinery pulsed with energy. Every movement depended upon pressure, temperature, and mechanical timing. A failure in one component could affect the entire operation. The machine never truly rested. Even maintenance became part of the production cycle. Crews inspected pumps, lubricated bearings, repaired cables, replaced worn cutting surfaces. The dredger functioned as a living industrial organism, requiring constant attention. Water added another layer of complexity. Unlike a factory fixed to solid ground, the dredger operated on a moving platform. Waves influenced stability. Currents affected positioning. Weather altered working conditions. The machine existed in an environment that resisted control. Operators constantly adjusted to changing circumstances. A strong storm could halt operations. A shift in current could complicate excavation. The machine was powerful, but it was never completely in command. Positioning systems were especially critical. Excavating the wrong area could create expensive problems. Channels required precise dimensions. Harbors required specific depths. The dredger therefore moved according to carefully planned sequences. Anchors and cables controlled its location. Measurements guided excavation. Survey teams monitored progress continuously. This was not random digging. It was industrial surgery performed on a landscape. Every cut had a purpose. Every movement followed a plan. The sensory environment aboard these machines was overwhelming. Engines vibrated through the deck. Steel cables groaned under tension. Pumps generated a constant roar. The smell of fuel mixed with river mud and machine oil. Steam-era vessels added coal smoke and boiler heat to the atmosphere. Workers lived inside a world of noise and motion. The machine announced its presence every second. Silence usually meant something had gone wrong. Yet perhaps the most remarkable feature of the giant dredger was its ability to make impossible projects appear routine. A harbor too shallow for commerce. A river blocked by sediment. A channel considered inadequate. The machine approached these challenges with mechanical indifference. It simply removed what stood in the way. Day after day, month after month, the result was transformation on a scale that few individual workers could fully comprehend. A crew might spend years deepening a waterway without ever seeing the final economic consequences. They saw pumps, cables, mud, machinery. What they were actually building was infrastructure, trade routes, industrial capacity, future cities. The machine connected local labor to national growth. But enormous power always creates enormous risk. Every rotating cutter, every steel cable, every high-pressure pump, every unstable spoil bank represented a potential danger. The dredger was capable of creating wealth and opportunity. It was also capable of destroying lives in an instant. And for the workers who spent their careers aboard these floating industrial giants, that danger was never theoretical. It was part of the job itself. The giant dredgers were built to conquer a problem. They were not built to protect the people operating them. Safety existed. Rules existed. Experienced crews understood the dangers. But industrial necessity often moved faster than industrial caution. The ports had to deepen. The channels had to remain open. The ships had to keep moving. And somewhere between those economic demands and the realities of physical labor stood the workers. The public rarely saw them. Newspapers celebrated expanding ports. Business leaders celebrated rising trade. Politicians celebrated economic growth. The dredger itself occasionally became famous. The crew almost never did. Yet every successful dredging project depended upon human beings, living and working beside machinery, capable of inflicting catastrophic injury. The danger began with motion. Nothing aboard a large dredger was truly still. Pumps rotated continuously. Cutting heads spun beneath the water. Conveyor systems moved material. Winches operated under immense tension. Steel cables stretched across work zones. The machine functioned because thousands of components moved together. That same movement created constant opportunities for disaster. A worker who misjudged distance could become trapped. A loose garment could catch. A hand placed in the wrong position could disappear into machinery. Industrial accidents often occurred with terrifying speed. The machine did not recognize experience. It did not recognize caution. It simply continued operating. Cables represented another threat. The largest dredgers relied upon massive steel lines to position themselves and control equipment. These cables carried extraordinary loads. Workers respected them for good reason. A cable under tension stores enormous energy. If it failed, it could snap back across the deck with lethal force. Men who survived cable accidents often described the event as almost invisible. One moment, everything appeared normal. The next moment, steel was moving through the air, faster than the eye could follow. There was often little chance to react. Water itself remained a persistent hazard. Unlike land-based construction, dredging occurred in an environment where falling overboard could become fatal. Workers operated near moving equipment, slippery decks, and unstable weather conditions. Strong currents complicated rescue efforts. Cold water reduced survival time. Storms transformed difficult work into dangerous work. Many accidents occurred not because of a single mistake, but because several small problems aligned at the same moment. The most feared incidents often involved collapses. The dredger removed enormous quantities of sediment from one location and deposited it elsewhere. These spoil deposits sometimes created unstable artificial landscapes. Workers moving across newly deposited material occasionally discovered that what appeared solid was anything but. The ground shifted, collapsed, gave way without warning. Stories emerged from dredging projects across the industrial world of men swallowed by mud, trapped beneath collapsing spoil banks, or buried under material that behaved more like liquid than soil. Rescue was often difficult, sometimes impossible. The machine that created new land could also transform that land into a deadly trap. Then there was exhaustion. Industrial machinery changed labor. It did not eliminate it. Large dredging projects often operated around the clock. Crews worked long shifts. Maintenance teams responded to breakdowns at inconvenient hours. Operators remained alert through repetitive work that demanded concentration. Fatigue accumulated slowly. A tired worker misses details. A tired worker reacts more slowly. A tired worker becomes vulnerable. Many industrial accidents began long before the moment of injury. They began with exhaustion. The psychological burden was substantial as well. Dredger crews lived with constant awareness of consequence. They understood what the machine could do. They understood what could happen when something failed. Every unusual vibration, every unexpected sound, every change in operating conditions demanded attention. The machine became part workplace and part source of anxiety. Workers learned to read its moods. They learned to distinguish ordinary noise from dangerous noise. Experience became a survival skill. Yet even experience had limits. Nature remained unpredictable. Storms destroyed equipment. Floods altered project conditions. Unexpected ground conditions complicated operations. The machine fought geography, but geography continued fighting back. Many workers spent years confronting that reality. And still they returned. Not because the work was easy, not because the work was safe, but because the industrial system demanded it. Families depended on wages. Communities depended on employment. Ports depended on dredging. The machine became part of a larger economic chain that connected local labor to national prosperity. This is the hidden contradiction at the center of the story. The giant dredgers created opportunity. They also consumed people. Not usually through spectacular disasters remembered in history books, more often through accumulated risk. Years of exposure. Thousands of dangerous moments. Careers spent operating beside machinery, powerful enough to alter coastlines. The workers paid the price, incrementally. One shift at a time. One project at a time. One generation at a time. Meanwhile, the ports grew larger. Channels deepened. Trade expanded. Cities prospered. The economic benefits became visible. The human costs became easier to overlook. Today, many of America's largest ports continue benefiting from channels originally created or expanded through generations of dredging work. The cargo moves efficiently. The infrastructure functions. The economic system operates exactly as intended. Yet beneath those waterways lies a largely forgotten history of labor, danger, and sacrifice. The giant dredgers are often remembered as engineering achievements. And they were. But they were also workplaces, places where ordinary people confronted extraordinary risks in pursuit of progress. The machine built the channel. The system built the port. But it was workers who stood closest to the danger, and without them, the industrial empire those waterways supported would never have existed.